Okay. So thank you all for attending. So thank you all for coming. If you have not joined our Slack yet, please do that. And also make sure you join our Taikai. Uh, and so now uh, Anna will speak. Um, yeah. So if you're ready.
Hi, yes, hi everyone. Thanks a lot for inviting me to
Hello.
BitHacks. I'm really excited to talk to you a little bit about my research and about different
Yeah.
problems that you can work on as you think about what you can do with technology for social good. So to talk a little bit about myself is I'm a PhD student at Columbia and I work in the computer science department there. And I work with social networks in issues regarding algorithmic bias on social networks. So we try to redesign certain algorithms like recommendation, what people do you connect with, what kind of content do you see, how does information spread in the network and things like that, with the idea in mind that you want to make sure that underrepresented communities are not left out of the loop or societal bias is not over amplified. I do some other activities in terms of like community engagement, and I'll talk a little bit about those. I think it's really for you as students. I think you have a bunch of very exciting opportunities to get engaged with it, and to begin with, BitHacks being one of them. So that being said, I'm going to share my screen with the presentation. Feel free to ask questions during the presentation, interrupt me. We can also discuss afterwards, but I don't mind talking during as well. So I'm going to start sharing now. All right. So as I said, most of my work is related to research and developing technologies for social good. There is, of course, a gap from research to practice, from the kind of products that you see or the effects of technology that you see in real life. And I'm sure that many of you are aware of the examples that I'm about to give on that. There are many reasons to actually think about the social good in when you develop different technologies, not only to not amplify inequality that exists in networks and in human data sets, but to make sure that you amplify the voices of those from underrepresented communities to support also research in climate change and in healthcare. And we know the recent developments in machine learning to process images related to different medical conditions that are very efficient, very quick, and can quickly improve the healthcare outcomes of different, as I said, medical conditions. There's recent works in machine learning and climate change to predict the kind of changes that we're about to see given the current state of the world. And those are some promising yet depressing outcomes that we're about to see with that. But that is just to say there are many ways in which technology can be used for good. And of course, I think one of the main roles is to use tech as a diagnosis tool because especially in machine learning, you're using very large data sets in which you're able to identify very large group level inequalities that otherwise for an individual it is just difficult to see. So with that in mind, there's been several criticisms to say of recent developments, especially in machine learning. And I just want to talk a little bit about those so we can give us a direction for the kind of scope that is actually going to be better. Perhaps some of you may know that that some of the machine learning algorithms that were deployed on or they were analyzed on how to predict recidivism rates in policing and on how aid police in detecting crime and predicting crime have had a terrible effect, right? So there's this study from ProPublica from a few years ago called Machine Bias, showing that if you have a data set with people's inmate information, like in jail information, and you're trying to predict who is going to recidivate, you're just going to end up amplifying a bias that exists against African Americans. And I think this is very telling, especially given the current state of the world. I'm in New York now, and there's a lot of protests still going on. There's a lot of cases of police brutality and a lot of bias that you can just see with your own eyes. And this is the kind of stuff that you see amplified in algorithms that are just like not looking into people's features. And this study was actually emblematic because it started a whole new field in CS. It started a whole new direction in people thinking about what is fair, what does an algorithm need to do in order to be fair. Does it need to be aware of people's demographics? Is that enough? Do you need to look at simply the outcomes or the process? If you're looking at algorithms per se, they just look fine. There's not like a bias that's just so visible with it. But when you work with biased data, you end up oftentimes amplifying that bias. And even more than that, the bias doesn't only reduce to data. There's a lot of other biases that people have studied in such algorithms. And more recently, we see a lot of cases in which technology gets very scrutinized. So in the way that fake news have been proliferating in a bunch of countries, from Brazil to Nigeria to India as well. And that speaks a lot to the way the information that already exists, like fake information existed before, it will exist from now on as well. But how do algorithms that spread this information could amplify the fake news that we actually see online? So there's a big question there to be tackled as well. And I think there's a recent, let's say like talk or a recent discussion by Jan LeCun from Facebook talking about like how like Facebook has some of the tools to deal with this, but it's very hard. Of course, it becomes a very moral problem of like what is fake news and what is not. And you can't let all the decisions to be made by an algorithm alone. So beyond that, there's a bunch of other studies showing how facial recognition can be biased as well. And maybe you've seen the recent news that, so these studies that facial recognition is biased showed up like a couple of years ago, but it's only until this year that some of the big companies like Amazon and Microsoft have pledged to not use facial recognition for tools such as like selling those tools to the police or to different civil authorities, acknowledging the fact that they can be very biased. So it took a while between the research side showing that something is not really ideal to the practice to really catch up with that. And this is one of the gaps that we often see. But this is also what makes research really important, to identify these kind of issues early on. And of course, there's a bunch of other examples from like showing how advertisement can be biased online as well, and many others. But in the end of the day, I don't want to talk only about how technology.
Yeah.
Yes, is there a question? No? Okay, I'm gonna continue. So I wanna also talk about how technology can be used for good and what we can do about it. So how can we like redesign this kind of algorithms and techniques to implement these interventions for social good beyond looking at the bad side of things? So the first part that I want to talk about is the research side. And there's many things you can do in that, from involving yourself with the current literature, reading a lot of the news are actually focusing on this as well, and thinking whether you want to try out different projects to see how this would work out. There's a lot of community involvement opportunities as well. And of course, in education, as you learn more about this, it's always great to think about the ways that you can give back to the community as well. So I'll start by talking a little bit about the research that I'm doing. And I work with algorithms like recommendation and ranking mostly. And we know that they've been used everywhere in the way that you search information online, the kind of products that you see, and the people that you get to be suggested to connect to, right? It's about the news that you see as well, and even the job advertisement and the opportunities that you see. So they're really, really, it's really hard to opt out of this kind of algorithms. But there has been research showing that there is a biased outcome in some of these as well, because you can end up with filter bubble effects. You can end up with echo chambers where it's really hard to see a different point of view, and with polarized outcomes. And that can be even worse when the polarized outcomes just means that you don't see certain opportunities that are actually relevant for you, or you don't see information that is being propagated through a network, like a link for a job ad, or like health guidelines about your community and things like that. There's been other ones about like the way our public presence is being affected as well. So in image classification, if you do a bunch of searches for like CEO or mathematicians or a bunch of things, you end up with a very skewed result. There is quite a diverse set of people in CEOs, in computer scientists, but the ranking algorithms oftentimes also bias these results. So you end up with a very skewed vision of what is actually available. And as I mentioned before in predictive policing, right, like that's one big area where bias is very pervasive. So in dealing with this, what does it mean for an algorithm to be fair? So I don't want to get too abstract, but there's been all these notions of like, you know, should I look at the outcome? Should the outcome of an algorithm reflect whatever was in it? So for example, if you're applying for a job and you have like 30% of people are men applying for that job, maybe you want that the people whom you interview to also be around the same ratio in the end, so to give the same opportunity to people. So you're looking at the demographics that go into the input and the ones that go into the output. And this has been formalized in like showing that you have this demographic parity in the input output that you get from algorithms. There's also like other lines of work that look at modeling the incentives that people have to apply for different jobs, for example, or controlling for people who have had like not as good conditions as everyone else to apply for those jobs, like income or family size or things like that. And for those, there's a model-based approach to make sure that you're not reinforcing that bias by just looking at the outcome. And this is the kind of work that we're doing here with social networks as well. So we're generally looking at the model of how do people connect to each other, how does a network grow, and what does that mean for example, recommendation. So that's one project that I want to talk a little bit about. There's a bunch of other techniques that I don't want to get into right now, but let's start with that. Are there any questions up to here? Let me know if I'm going too fast or too slow.
I think this is a perfect pace.
All right, thank you. So I'll continue from this. So there's one project that I particularly want to share with you guys, and there's this project that tries to formalize what does it mean to have a glass ceiling in a social network. So I'm sure many of you know the notion of a glass ceiling that comes from industry research, that is this like unseen and unbreakable barrier keeping women and minorities from rising to the upper rungs of the corporate ladder. And this has been shown to exist in many industry applications. The Wall Street Journal shows that only a handful of women make it to the C-suite, but it's also something that's present in online networks as well. There's a Twitter study showing that if you basically condition on the fact that you are a man, you have way more retweets and followers than otherwise, and that is regardless of the content. Again, also on the BLP, which is a network of computer scientists, in which you see every publication that happens in computer science and their authors, you also see that the percentage of women decreases much, much drastically for prominent researchers, the ones who have a lot of citations or a lot of works. So this bias, of course, comes from like a societal issue that maybe some people are not interested in the field, maybe perhaps their interest is because they are like, it's easier for them to have other domains of study and things like that. But it shows something more than that. On average, there is an inequality. It shows that there is just really difficult to get to a very high position of power, to say so. So to give an example of that, this Wall Street Journal article was really interesting because it shows a study from about 134 companies, and they're looking at men and women. So if you look at the very top, this is the percentage of women at the entry level of the workforce. So they're 46% women, which is quite equilibrated. It's not that women are not interested in these companies, but at the entry level, they're very well represented. As you go down on this graph and you're moving up on the corporate ladder, you see how the percentage of women in this case just drops to much, much lower. So from manager to director to VP and then up to C-suite, the percentage of women just drastically drops. So if you would have looked at an average, you would have said, well, maybe the inequality is not that bad. But when you have this differentiated look, this is where you see inequality much more pervasive. So what do we do with this information? We were interested in looking at how on social networks, you know, the power that you have on social networks is your connections. And given that, what happens when you have recommendations to connect to each other? How does that change in the nature of a network? So we made a study on Instagram. We have a big data set from Instagram in which the data set was collected in a biased way, not intentionally, but it just happened to be so. So my collaborator started from the founder of Kevin Systrom, the founder of Instagram, Kevin Systrom, and collected his followers and their followers, and he got to this like big sub-network of like 500,000 people. And like we have having their gender, in this case where we're just looking at men and women and looking at their number of connections, it just showed that on this particular subset, male were a minority, but it had a very high degree. And meaning they had a lot of connections, a lot of followers, a lot of comments and things like that. And of course, it kind of makes sense because you started from the founder who's already very popular, and he was probably he's connected actually more to men, and so on. So it doesn't really speak about any societal issues. It's just the problem of the data set. But what happens if you look at recommendations on such a data set? So when we apply these like recommendation algorithms to see like who should you connect to, who should be your next friend, and a lot of them are based on who's your friend of friend. And in this case, we show that, well, if you look at very popular people, you end up reinforcing a lot of the connections for the people who are already very popular. In this case, were the men, although they were a minority. So you end up with a very disproportionate view of who is actually popular in the network. The interesting part was that this data set was collected a long time ago, before Instagram had any recommendation algorithm in place. I remember that I was there, but like you couldn't really like, you didn't have suggested friends. You would just like search yourself for friends you already knew in real life. So that kind of shows this is like a very organic way to connect to people. So then when we apply these recommendation algorithms, you really see what happens with an organic network. How is that affected by recommendation? And in this case, it was simply affected by the fact that if you connect with friends of friends, you just end up with more connections if you already are very popular. So, right? So in this case, we had this, this graph is a little bit abstract, but maybe I'll just go over it quickly. We just noticed there is a very high glass ceiling to describe it. So even on Instagram, on the kind of popularity you can get there. So in blue is just the, on the x-axis is just the number of your connections. And on the y-axis is just the percentage of women among those with that degree, right? So for degree 1, everyone has at least one connection. It's a connected network. There's about 50-something% women, 54, whatever, it's what the whole network shows. If you look at people with degree with at least 5,000, there's no women there, it's just men, because that's how the data is, and that's fine. Nothing new there. But when you apply recommendation algorithms, and these are the one in green and red, the fraction of women towards when you look at very popular people, just decreases so much quicker to 0. Right? So you see the difference between red and green and the blue. And for red and green, it just like drops to 0 like super quickly. And they have just much, much fewer degrees in general. And so that shows that, you know, it's not that an algorithm will reproduce whatever is in a network. Maybe that's fine to just mirror whatever society is doing. But in this kind of cases, it's just amplifying something. And this is a way to measure how much is it actually amplifying this kind of inequality, to say so. Whether you want to fix that inequality or not, that's of course subject to like interpretation. Like, do we really care whether people are more popular on Instagram? We don't want everyone to be equal. Like, it's just a natural way of being. But this becomes important whether like if you end up with recommendations that are about like jobs or educational degree. Like I see actually a lot of ads on Instagram about masters in data science, in computer science, in a bunch of other fields. I think it's weird for me to see that, but I see it. So I think that's where it starts to become a little bit more important. And of course, it's nothing in the algorithm itself that's just malicious. You know, the algorithm is just looking at your friends of friends. It's not about intent. It's about the subtext that you get from this kind of inequality. So, okay, I should have removed this. This is just like a bunch of definitions for which we're using like an actual theoretical model to see how the network grows and to see, to capture exactly why is this happening? Where is this like amplification coming from? And it's coming from a very simple fact that people who are similar connect more with each other. So if you have a minority group, in this case, it was the women in this network, and they connect more with each other, that just like kind of means that yeah, you have a homophilic network. So then in that case, recommendation and ranking reinforce this, and you end up with more polarized networks, and you can actually show this given this effect in mind. And of course, polarization, you know, we see it everywhere in the way we read the news. It's not a horrible thing in itself. It's bad when it just limits your access to certain opportunities, which is the case here. So we did the same analysis with other data sets because we thought maybe Instagram is different. Or, you know, maybe people don't care that much about an Instagram, but it turns out it becomes more and more relevant every year that I talk about it, just because of the kind of advertisement that I see on Instagram. And it turns out you see similar effects on other data sets. You see it when you go on the BLP, the Network of Computer Scientists, and you look at who has a lot of citations. There's a lot of internal listers on giving like job advertisements or postdoc positions or where to apply to grad school or things like that that happen in this network of CS, as I'm sure it happens in every other field. So that's where it becomes important to be aware of these issues. So, okay, that's it with the research. If you don't have questions about this, I'll move along for community involvement and what we can do about that. So there's a bunch of ways in which I think the computer science communities actually have increasingly become amazing at doing ground field work, at including students and more junior students in understanding what issues are at stake, how to build products that are important for society and that end up promoting social good in the end. One community that I've been a part of that I want to talk to you about is this group called Mechanism Design for Social Good. So it's founded by two of my friends, Rediet and Kira. Kira is now at Columbia as well, and is now we're co-organizing with another person, Irene, as well, who's now faculty at Stanford. And it started from a reading group of people just reading, grad students reading papers. And it ended up now with like a big group in which we have working groups in which students and faculty together like present each other's ongoing work or talk about different issues or have a reading list and talk about different papers. And we also invite speakers to talk about their work. So we had some great people last year too, like Kentaro, who works in ICTD in development, and Pauline, who's doing law, and she has this amazing case about how to deal with online discrimination or bias in advertisement. It's a very hard case because it's a very difficult thing to audit. You don't never know. You might have seen the Facebook case from last year in which she was also involved. It's really hard to know if you didn't see an ad. So it's really hard to replicate and to make an experiment to see if advertisement is actually biased or not. And Elisa, who also worked on the computer science part of that, on how to redesign advertisement, that, you know, advertisement, it has to be targeted. It doesn't matter if you see random stuff that you don't care about, but it matters if you don't see jobs that are actually very related to your CV. And how do you formalize this? What does it mean to be related? It's a very difficult problem theoretically, and also, as Pauline showed us, in practice too. So we're so far from solving it, but we get some insights of why this is actually difficult. I mentioned working groups, and we organize a workshop, and Brian here like helps us with the different working groups, and again, like people get together online and talk about their works, or have a reading group every 2 weeks on different topics. And a lot of these working groups are actually related to social good, and I'm sure like now there's a lot more groups that do this. I think I don't think this is like the only initiative doing this, but I wanted to give you an example that if you're interested in a topic, I think the emergence of this like online working groups is a wonderful idea for you to get involved with your peers and work on things together, engage faculty or practitioners that you want to care about their work as well. Whether you're going to go in industry or academia, it doesn't matter. And the last part is on partnerships too. Like we're trying to partnership with actual organizations, from a bunch of them from Africa, that ask us for how how to use different technologies, or they come with us with different problems, especially in agriculture, how to streamline agricultural issues or to provide resources from the state to different farmers or things like that in order to make it more efficient. And there's a lot of questions there also of how do you do that in a way that like helps people, but it's also, you know, it actually streamlines the process as well. So there's a lot of things that you can do on that side. And the last part is in education too. Like I think this kind of initiative in BitHacks is really wonderful, and I really hope to hear more about it and to hear how this week went. The other thing we're doing this AI for All summer camp. And it's a summer program with two faculty at Columbia. One of them is my advisor on the right side, Augustine, and the other one is Desmond, who works in social work. And we're doing this program for students who are interested in learning AI and who come from different underrepresented groups in trying to improve diversity in CS. And maybe you have seen like diversity in CS is just pretty terrible at the moment. And it's something that I think we have to start really early on with working and getting people interested in. And it's basically a program for also high school students, in which we can serve as teachers and mentors, and the high school students who served from last year come again. And it's a very nice community building exercise that we can do. And I'm sure what I'm trying to say is that I think, especially in computer science, these kind of initiatives become much easier to drive on your own. And especially, I mean, I guess especially now with the online, moving things online is just much easier, and you need much fewer resources, as I'm sure that was the case for BitHacks as well, and for many others. So I think with that in mind, I also want to thank you, the organizers, for, you know, putting all of this together. And I'm happy to answer any questions that you might have on this, and we can start the discussion there.
Yeah, thank you, Anna, for speaking with us. I think everyone was able to learn more about bias, as well as more about your research. So I just had a quick question. Could you possibly go more into exactly how bias forms in models? Like, for instance, like the facial recognition issue that you had described earlier.
Yeah, so in facial recognition, there's one study by, since I'm sharing my screen, I can just like share that with you as well. So Timney Jabru and George Bolamini have a wonderful study about this. It's called Gender Shades, and it's about how facial recognition, wait, I'll look this up. It's about how facial recognition that is trained on biased data will reinforce the bias that exists. So they made this study, it's just on this website, gendershades.com, that there were the software from IBM, Microsoft, and Facebook doing facial recognition. And it's basically a very simple machine learning algorithm that takes apart a picture. It's the way that you learn the digits as well, in one of the first classification tasks of machine learning. And by doing so, by training it on a data that was very non-diverse, that was mostly like white people in that case, it just like misclassifies people who are Black. And you end up, what you care about it, you care whether this algorithm is robust. So on average, maybe it has a high accuracy rate, so a low error rate, right? By just like seeing if it classifies a person as male, female, and the race correct. And if you, given this categories, you can end up with an error rate that's like pretty low in general. But if you look by groups, and if you look at, the error rate for white men is like 0% or something. The error rate for white women is like something percent, and the error rate for Black women is just like really, really high. So that's kind of what it ends up being, ends up happening. And there's also like an NPR podcast with Joy that I think is really interesting, on just like how does this bias being recreated. And in this case, again, the algorithm is very simple. It's just like it takes a picture, it breaks it down into features, and in the pixels that it has, and it just classifies based on that. So, but the training set is the one that's, in this case, biased, right? So it's not the algorithm that has any like malintent to do so. So it just like associates it really quickly with the incorrect version of it. There's also a recent discussion, I think, that I saw on Twitter on another algorithm. Maybe you've seen this. This was like a big discussion in the way like AOC and people like that were being misclassified. But I can look it up if you want to ask another question, so you don't get to like spend time watching me search Twitter.
Yeah, so I just had one question, and I wanted to clarify something. So, just to clarify, a glass ceiling is basically some sort of barrier that keeps a certain demographic from from rising beyond a certain level, right?
Yeah, like it's like if you say what's a probability for someone to get to a high position or for someone to acquire a number of connections. So then a glass ceiling is like, oh, maybe that condition on the fact that someone is like a woman in a particular case, maybe that probability is 0. That's the glass ceiling, that you just cannot get to that level.
Okay.
And you can formally define that depending on what kind of scenario are you looking at. So in the case of social networks, it's easy to look at that just because you can say, oh, this is a study. You can say, well, what's the probability for me, given that I just entered the network, to have a degree of 100? That probably will be a certain number. Okay, what's the probability for me to have a degree of 200? That's another certain number based on the model assumptions. And as you end up with what's the probability for me to have be in top 10% of people? And then you see that with certain models, especially with ones with two communities that are very homophilic, you just end up with a probability of 0. Or as the network grows, you end up with minority just having a 0 probability of ever achieving a high degree.
Okay.
And this is the study that I mentioned. Let me know if you can see it well. There was an image. Yeah, this guy mentions how an image of Barack Obama got unsampled into a white guy because of the way this image recognition software was being deployed. And this is how it does for different people. So for this researcher, Robert Ness, and for Alexandria Ocasio-Cortez, you can see how it changes them. I thought that was really funny and related to, and I just saw that yesterday, so I've actually meant to include it in the presentation too.
So if anyone else has any questions, you can unmute yourself.
Yeah, so going off of Pranav's question on the glass ceiling, is there a way in our model to remove the glass ceiling or mitigate the effect, or is this just a data set issue?
No, so I think that's a good question. So for example, it really so there's a few things embedded here. Is what kind of model do you use? Is that a realistic model? And what are the components that lead to a glass ceiling effect? So for example, let me see if I have this here. Yeah, so for example, a classic model that has been shown to exhibit this kind of glass ceiling effect has a minority majority partition, has two groups. It has a way of connecting that has preferential attachment, meaning that the probability for you to connect to someone is proportional to that person's degree. And that model has been shown to be very relatable, especially in online networks. It leads to a very skewed degree distribution that you see in a lot of online scenarios. And homophily, the fact that you have a higher tendency to connect to people similar with you. So if you have these three parts, then you end up with a glass ceiling effect. And you end up with it mostly whatever recommendation algorithm that uses your links you're gonna use. If you wanna remove that, what you can do is is to adapt the algorithm to one, understand or quantify what does it mean to have a glass ceiling effect, what is the inequality that you're trying to fix, and to kind of overcompensate for it in the way that you do recommendations. So you can reweight some recommendations to compensate for that. Or you can look at, or you can try to remove on the long term some of these effects that you see here. So maybe you promote diversity. If you have two equal groups, you don't have a glass ceiling effect. It's just two equal groups that have the same probability to do anything, right? Or if people don't have such a high tendency to connect with people who are similar to them, again, you can kind of help this effect. So if everyone connects with everyone with the same probability, again, you don't get this kind of effect. And that's something that you can do through nudges or certain efforts to promote, this kind of, to counteract this kind of effects too. So it's not only an algorithm, it's the way you interact with the model as well. And again, like it really matters what kind of model you use. Very complicated models are just really hard to use. Some of them are more applicable, but it's hard to find a balance between a model that you can work with and one that's like applicable and it makes sense and you see evidence, like empirical evidence that it's helpful.
Okay, thank you.
Thanks.
Okay, any more questions? Okay, I'll ask one more question then. So this is kind of unrelated to the talk, but why exactly did you choose to pursue a PhD in computer science, and why exactly did you choose this exact field of study?
Yeah, no, I'm happy to answer this. So I left some time at the end for like general discussion as well. I realize I speak faster online than in offline settings. So we can talk more about that. But I was really interested in networks in my undergrad too. So I did my undergrad in math and was really interested in graph theory, also in machine learning. And initially I actually applied for math programs, but throughout the application, I kind of realized I was reading more and I was reading about all these professors and their works. And I realized that I really care about, you know, things that are related to sociology as well and about like the impact of all this technology on communities. And I was reading that in my last year of undergrad. So it was really like pretty late to do that. But then I realized that I was lucky to find advisors who were interested at the time as well in this. So it, like this field of like working with algorithmic bias or like the effect of algorithms on inequality was kind of growing more. So I just like ran, honestly, like when I visited Columbia, I visited for math. And then I just found my advisor and I was really interested in him. So I just kind of switched my application to computer science and continued from there with the rest of them too. But I was really interested in the research side. Like I really liked reading the papers. I liked reproducing experiments or thinking about my own stuff. And that's why I ended up like doing this works too, like in starting the PhD as well. And I think I realized as I like moved towards a PhD that is very different from like a few years ago PhD. I felt like maybe a few years ago all the work would be research related. You only focus on writing papers. It's a very solitary work. But now it's really, really different. There's a lot of different kind of works you can do in a PhD. And there's a lot more interdisciplinary work that you can do. And I have friends who work in between CS and econ. I have friends who work between like sociology and CS. And it's a much more collaborative environment in which you can also do a lot of community building, and it's much nicer in that way. At least like I really appreciated that.
Okay, yeah, that makes a lot of sense. Yeah. Yeah, just one more thing. So, everyone here is actually either an undergraduate or a high schooler. So, how would you, or what would you recommend for everyone if they're interested in getting into artificial intelligence, or if they're interested in researching more about this?
Yeah, I think honestly there's a lot of news that you can start with and kind of look where like the kind of papers that you are being led to read from those news. So that's kind of how I started to be interested in this too. Like I was reading about algorithms of our recommendation and influence, like how information spreads, and that's how I get to like papers that I was interested in. And I think that's a way that really motivated me. Like I definitely had to take some time to learn the tools and to learn CS because I didn't do CS in undergrad. I don't think that's an issue at all. I think what really matters is you find a subfield that you're really passionate and like you read about it, and the reading I think is the most important. And it's also like a lot of professors I think are also, or grad students even more, are really willing to talk to you about their experience and about their works, and it's a great way to just like find out about this. I also like I send a lot of cold emails during undergrad and also during grad school too, to just like ask to talk or ask about research or for them to send me a paper or things like that. And I think that's a great way to start there. If you're thinking about like I think in the undergrad level, it's a really good time to start doing some research if you're interested in that. I think that's where you can like really explore throughout the summers or during the year with different professors and just like engage in a project, see if you like it. I think in CS now, I know there's like a big hardship with doing that in this period, right? Like I don't know who's doing an internship this summer, but maybe some people can still do that. But I think in CS there's a lot more opportunity in doing remote work, and people are adapting to that. So I think it's a good place to be for that. Like none of our work, we still work with undergrads. We're still doing the summer school for high school students. A lot of that work wasn't really impacted. So I think I hope you're not feeling too discouraged in pursuing this during this time too.
Yeah, Pranav, do you have anything to say?
No. Does anyone else have any questions?
And also feel free to email or message me about all of this. I'm happy to talk more with any of you.
Okay. Yeah.
Yeah, Pranav, maybe send Anna's email in the chat.
Yeah,
So
I will do that.
okay.
And I will also send it on the Slack later.
Yeah,
so
sure.
you guys can contact if you have any questions.
Yeah, so I guess we'll just wait for maybe 1 or 2 more minutes just in case someone comes up with a question they would like to ask. Otherwise, I think we'll be done after that.
Yep.
Sounds good. Yeah. I have to adjust my pace for the online works. Definitely finish much sooner.
Yeah.
But in the meantime, I'm curious. So what have you guys been doing for this? Maybe anyone can answer that, or how has BitHacks been going this week?
Pranav, do you want to answer that?
Yeah, it's been going pretty smoothly. I think the participants have been able to learn and they've been able to, use the resources to work on their project. If anyone wants to answer how their experience has been.
Yeah, if you guys don't want to say it out loud, you guys can obviously just type it in the chat.
Yeah.
Sure, I can say something. So beforehand, I would always use a model or algorithm that someone else trained, so pre-trained algorithms. But I think BitHacks is the first time where I realized that I could create my own algorithms, and I'm really thankful for BitHacks and for my team for pushing us in that direction.
Yeah, no problem. Yeah, thank you for that. Yeah, thank you. I'm glad that you were able to learn more about algorithms and how exactly to implement them. So, yeah.
Okay, I just sent the email in the chat, so if any of you guys have any questions, yeah. Okay, so if that is it, thank you, Anna, for speaking.
Yeah, thanks a lot for inviting me. I hope it was helpful, and good luck with the rest of the program too.
Yeah, thanks. Talk was really helpful, and I'm sure all of us learned a lot. Yeah, so thank you. And thank you for everyone who attended and asked questions and participated. Thanks.